All right, here we're going to talk about access control lists. We'll look specifically their purpose, their operation, how do we configure them. We'll look at IPv4 access control lists. We'll look at a couple examples, and we'll do some configuration and verification, and then we'll be done. And in a follow-up video after this one, I will do one on IPv6 access control lists. Once we understand the fundamentals, you'll find that IPv6 ACLs are pretty easy because it's pretty similar. So there are multiple uses for an access control list. I narrow it down to two major uses, which would be filtering and defining interesting traffic. Filtering is what we're going to focus on today. So after I go through the function, through how they operate in their function, then I will go through. I'm just going to discuss specifically. We're just going to go through filtering. But when I talk about defining interesting traffic, so we have one thing to filter where we can permit or deny certain traffic from going to certain places. When I talk about defining interesting traffic, I'm talking about using access control lists to do something else other than filtering. For example, network address translation. If you've worked with NAT before, or even if you haven't, we'll do a quick roundup of it. Basically, the function of NAT is to take internal, private, unroutable addresses, translate them to a public routable address to go out on the internet. We use an access control list with NAT to define what addresses will be translated. Right? So what it's doing in my terms, or the way I'm using it, is the interesting traffic is those private addresses that will be translated as they go out to the internet. Another use would be what's going to be encrypted over VPN. You can use an access control list that when that traffic, the traffic specified, the interesting traffic specified by the ACL, go to a certain destination, that my VPN will be built and that traffic will be encrypted over the VPN. So we talk about interesting traffic. I'm thinking of, we use an access control list to define particular hosts or particular networks to do something other than filtering. But now we're going to focus on filtering for the rest of this. One of the things ACLs do is they use a wildcard mask to determine which hosts or networks to filter. So if you think about it, when you take an IP address and you AND it with a subnet mask, what falls through is that network number, right? With a subnet mask that I'm sure all of you are used to at this point, ones are what matter. When we match a 1 and a 1, it means that that's what we want to fall through is the network address. With a wildcard mask, it's the exact opposite, in that a 1 means I don't care what's there. I don't care what's in that bit position. Whereas 0 means you need to match what's in that bit position. Okay, so my example here, let me get my pen out. My example here, and I will go over these and we'll break these down, we'll do them together, but we just want to look at this part right now. What it's saying is we're going to permit the things in the 192.168.1.0 network to go to host 10.10.110. No reason, just an example, right? But we matched this 192.168.1.0 network. I could put anything in this last octet, anything I want, because the rule is zeros means I must match. So the first 3 octets have to match. So when traffic comes through with a 192.168.1.0, it's going to be processed against this access control entry here, because the zeros mean, yep, 192.168.1 matches. Anything at all could be in this last octet. It doesn't matter. So it's the direct, you can kind of visualize that it's the opposite of a subnet mask. And we can do them bitwise. We don't have to do them full octets. But a 1 means, doesn't matter what's in that position. And a 0 means it has to match what's in that position. And it figures out what it matches, and then it's processed if there's a match. So we have multiple different types of access control lists. We're going to look at just standard and extended, and we could look at time-based and dynamic. But here we're just going to look just at a general standard and extended ACLs. We can filter traffic based on source only when we configure a standard access control list, so I can only filter based on source. The number for standard ACLs is 1 to 99 or 1300 to 1999. Extended ACLs are give us a little more granularity, a little more control over what we're doing. So if we want to do more, we can actually, with an extended, we can use source and destination IP address. Well, we'll have to. We can use a source, we could use host, or we could use any, but we'll still use a source and a destination. So we use a source and destination address. We can use source or destination TCP or UDP ports, and we can use protocol types. The numbers for extended ACL is 100 to 199 and 2000 to 2699. So I can do, here I just discussed number. I can also do a named access control list, as we'll see in a little bit here. A name is a little more descriptive, so if I name it, that allows me to kind of know what this ACL is supposed to be doing. Not to say that I couldn't write a description in there, but it is a little more descriptive, sorry. And lines can be added or deleted. Now there is a new form of a numbered access list that looks just like named, except for we use a number. But in our traditional numbered access list, we can't just add a line wherever we want. Okay. With a named access control list, we can add and delete lines within the whole list. And lines are actually access control entries, which I'll talk about. I don't know if I talked about them yet. I probably will in a little bit here. How can we apply ACLs? We can apply one per interface, per direction, per IPv4 and IPv6. So if I'm running IPv6 and, I'm sorry, the other thing is we have the direction of in or out, and it's from the router's perspective. Okay, so first let's look at this. One per interface, per direction, per IPv4 and IPv6. Let's say I have two interfaces, one here and one here. Okay. I can have two IPv4. I can't really write a P very well. I can have two IPv4 ACLs per direction, right? Because I can have one per direction, so in or out. And I can have two version 6, one per direction, in or out, times the number of interfaces, because I can apply it to the interfaces, to both interface or to all interfaces. So if I have 3 interfaces and I'm running IPv4 and I'm running IPv6, I can have 12 ACLs, because I can have 2 applied in and out for IPv4, plus 2 more for IPv6 in and out. That's 4 times my 3 interfaces is 12. So hopefully that helps you understand. And to go back to the flow, when we're trying to decide whether we apply our ACL in and out, we need to look at our flow of the flow of our traffic. And it's from the router's perspective. If I'm sitting in the router, is the traffic coming in, right? Or is it going out? So it's dependent upon, if I'm sitting in the router, which direction is my traffic going when I decide our in and out. So now if we configure standard or extended ACLs, where's the best place to put them? If I configure a standard ACL, I want to configure it closest to the destination, because remember, I can only filter based upon source. So if I want to allow these guys down here, all the hosts, to go to this server up here, if I apply my standard access list right here, and I say permit 10.10.10, and I say going out, it's not very efficient. And then I deny also everything else. Now right now on my easy little network, that's probably not much of a problem, but if I have multiple, right, different LANs, now what I've done is, since I can only filter based upon this one address that I actually wanted to permit to go up here, I deny everything else. And the other thing I could do is do a permit any. What if I only want to allow some of this stuff? So what happens is you run the risk of filtering things too soon if you don't wait until you get right to the destination. Or if I just want to permit or deny one or the other. Maybe I want to allow this one to go over here, but I don't want to allow this one to go over here. We don't want to be filtering one or the other. So if I deny, say, PC1, and I deny it right here, when in fact I really just don't want it to be able to go here, or I should say to PC3, what happens is I deny PC1 before it can get to server, which it is allowed to do, for example. So let's get rid of our ink real quick. Oh, sorry. And so what I want to do when I'm doing a standard is say, okay, I'm going to go closest to the destination. So if I want to permit both of these PCs to go here, then I would do a permit statement going out, right? Because as the traffic comes up through, it's coming in gig 01, and it's going out 03 to get to the server. And if I want to deny PC1 going, say, to PC3, or maybe this guy's an administrator, he gets to do whatever he wants, I don't know. I want to go closest to the destination because I don't want to deny PC1 right here, right? Because as soon as I do the deny right here, it also can't go here, 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 right? So I would do a deny statement again, and again going out in this case. With our extended, we want to go to closest to the source, and that's really saving bandwidth. There's no like real requirement, but with an extended access list, because I can filter on so many more things, I want to do it as close to the source. Why let traffic that I know I'm going to deny, let's go back to our PC1 here, and we know that we're not going to let him go to PC3. Why, when I use an extended, and I can filter it right here specifically, I can say, okay, from source of PC1 to destination of PC3. I can even do it on a particular port, and that's the only thing I'm denying. I wouldn't want to deny. Sorry, well, I wouldn't want to wait to here deny it. We don't want to send the traffic all the way over, all the way around, and be like, oh, I guess I'm not really allowed to go there. So with an extended access list, we can save on bandwidth and CPU processing by applying it as close to the source as possible, because we can be so specific. So on this one, we could create an ACL, apply it inbound on branch 1. That would deny the source of PC1 to go to the destination of PC3. And I referred to it a little bit earlier, and I referred to a line as being an ACE. I could add and delete ACE. An access control entry, or an ACE, is a line in an access control list. So we can make multiple lines of match conditions, right? Permit or deny. And the router is going to process those sequentially until a match is made. Right, so a packet comes in, I've got 10 access entries in my access list. When that packet comes in, the router will sit and try to match it to entry 1, then entry 2, then entry 3, 4, 5, so on, till it gets to 10. If it doesn't match any of them, there's an implicit deny all, and the packet will be dropped. If a match happens, then whatever the access entry tells the router to do, it's going to do, permit or deny, right? But if I get to the end of the access list and nothing has matched, then it will be denied. There's an implicit deny there, and the traffic will be dropped. So let's look at a couple examples. Let's look at a standard access control list. So with this standard access control list, here are my rules. I want to say only PC1 and PC2 can go to the web of SRV. PC1 can't go to any PCs inside of branch 2, so you can't go to anything inside of branch 2. PC2 can send files to PCs on branch 2. Now, in this simple topology, I'm only showing one PC, but let's say it's a LAN and we have multiple PCs. We're going to allow PC2 to go to all the PCs. So let's look at this first from a traditionally numbered format. I do access list, and then, right, the number 1 to 99 would specify that it's standard. We're going to permit host 10.10.10, or I'm sorry, 10.10.1.10. So our first one, we're sitting on HQ because the rule is what? Closest to our destination if we do a standard. So what I'm trying to do right now, I've got to accomplish this with, if I'm going to use a standard access control list, I'm going to have to accomplish this with 2 different ACLs. So the first thing is we want to allow both the PCs to go to the server, right? So that's our first set. We match PC1 by doing 10.10.1.10, the host. We match PC2 by doing 10.10.1.12, the host. Access list 1 permit host 10.10.1.10. Access list 1 permit host 10.10.1.12. Remember, there's an implicit deny at the end, so after that everything else will just be denied. And then we apply it to our gig 3 interface going out. So we created these on HQ, right? And we apply it going out of the gig 03 interface. Now we want to accomplish this part. PC1 can't go to any PCs inside of branch 2, and PC2 can send files to PCs on branch 2. So we could do it. We could go with an access list. Okay, I'm going to do it the way it's written, and then I'm going to explain something here. So the first thing is we got to go to branch 2 now because we're going closest to the destination. We do it access list 1 deny host 10.10.110 because PC1 can't go to any PCs inside of branch 2. Then we do an access list 1 permit host 10.10.112 because PC2 is allowed to send files. Now we can't specify what they're sending and receiving. They can do anything, right? Because the only thing we can filter on is based on source when we do a standard ACL. And then we'll apply it to this interface going towards the PCs on branch 2. Another option I could have done is, remember there's an implicit deny all, so I could have not written this statement and then just had the permit statement and deny everything else. So that certainly is a possibility, but I think this works as far as if I have this in here and now I want to do, say, a permit any to allow everyone else to do what they want, or permit any in this case. So I can, what happens here with this implicit deny all is that I'm also denying other folks going out branch 2, or going out gig 2 on branch 2, branch 1 HQ going out. And that's fine, it might be exactly what I want, that could be exactly what I meant. But I could also do a permit any at the end to allow everyone else through, which means then I would need this statement to deny. Otherwise I would permit and then permit any, which means I'm permitting everything, which means then if I did it that way, I could just do the deny statement and then do a permit statement. So there are multiple ways to do that. I hope I wasn't massively confusing just now. And just to say that there are multiple ways to write what I just wrote. I just got rid of my ink real quick. So this is just one way of writing it, and I wrote it just kind of the way that it's worded for ease, but I did talk about 2 other ways we could do this. Now let's look at named standard, and I just did this part instead of doing them both again. So if I want to do this same thing, but I want to name it, I would do this down here. So IP access list, I have to tell it it's standard or extended and give it a name. This is just the name I chose to give it. And I permit host 10.10.110 and 10.10, oh shoot, a typo, it should be 1.12. Shucks. But anyway, so this is just the named way of permitting these 2 guys up here, these 2 guys. We still apply it to HQ. And then again, apply it to the gig 03 interface going out. So just numbered, named. All right, let's look at extended access control. We're going to do the same kind of thing. And again, there were multiple ways I could do it. I wrote it out very specifically to show that you could do it very specifically. But there's still multiple ways I could do that. Could have done it. Let's go ahead and go through that. So we're going to do the same thing, but we're going to make it extended. So again, same thing. PC 1 and 2 can go to the web of, see now the difference here is I'm going to be really specific about web. I said web before, but I couldn't really be specific. I couldn't specify the port. It could really just go right to SRV or the server. PC 1 can't go to any PCs inside of branch 2, and PC 2 can send files to PCs on branch 2. So standard, I would do it on, wow, that's not right. We would not do it there. We're going to do that on branch 1, right? Sorry about that. So on branch 1 is where we're going to configure our extended ACL, right? Because when we do an extended ACL, we want to filter as close to the source as we possibly can. So we do access list and an extended number, which would be 100 to 199. So access list 100, permit TCP host, the keyword host, it's just a keyword of 10.10.110. So we're going to permit this guy going to, so the source of the traffic, the destination of the traffic, going to 172.18.1.10 equal to 80, right? 80 is the web port. So now I can be very particular because now I can filter source, destination, and port. Next one, we got to permit PC2. Now in this example, I specifically did the PCs, right? Because if I had more PCs, which I'd like to think if you had a network, you had lots of PCs, right? Because there's only 2, like if you're just playing around, you could have just done that whole 10.10.1.0 network. But I was very particular to the PCs because likely you'd have more than 2 PCs coming off a switch. So I did access list 100 permit TCP host 10.10.112 to deal with PC2, going to the host of 172.18.1.10 equal to web. So we took care of this part. And now PC1 can't go to any PCs inside a branch. Now this time, because I said any PCs, I did then use the network number coming off of this branch because I said any PCs. So I could have lots of PCs coming off of here, and regardless, PC1 can't get to them. So we do an access list. What did I do there? Oh, I did the permit statement first, so I didn't do it in order. So let me go down to my deny statement first. Access list 100 deny IP host, so we're denying PC1. Going to a destination of 10.10.20 with a wildcard of 0.0.255. What does that say? That says we care about 10, we care about 10, we care about 20. We don't care what this last octet is, right? So what we're saying is anytime PC1 can do a lot of things, but what he can't do is he's denied going to anything off of this LAN here. So we took care of that with that statement. Now PC2 can send files to PC on branch 2. Now here's where I did things a little differently. I did it the same way as I did a standard, but I could have done it a little bit differently depending on the file transfer type, right? So access list 100 permit IP host 10.10.112, that's PC2. We're permitting him. And we're permitting him to go to the LAN of 10.10.20.0. So we're allowing this guy to go to the PCs here. Now, because of this, he can do right anything, right? One of the other things I could have done is instead of doing a permit all IP, I could have done, say, TCP instead of IP, and then at the end, kind of like I did up here, and then at the end I could have done equal to FTP if I knew I was using file transfer protocol. Just another way, another option. And then here, because I did my deny statement and I want to allow everyone else, whoever everyone else is, assuming my network's much more complex than my 3 routers and 3 hosts, I then knew there was an implicit deny all, and so I let everyone else do anything they want to do. All right. And I didn't have to. I could have done a bunch of ways. I didn't have to be this specific up here. I could have not, based on our little network, not done the deny statement and just left the deny all at the end. That's fine too. What you have to do is look at what you're trying to accomplish and pay attention to unintended consequences, right? Because if I went to put the permit any on here, we would have actually denied other traffic that didn't match these. So we would have denied branch, maybe going to PC3. And we wouldn't have wanted that. And so then now we just have to go ahead and apply it to closest to the source. Closest to the source I can get is gig 02 on branch. And we apply it coming in because the traffic would be coming in from the router's perspective. Another way to do this, so if we looked at named, like I did the last one, we do, and again, let's get rid of that HQ. I got rid of my ink and I just want to be clear again that that is not HQ. That's branch 1, or we do everything with extended access control list as close to the source as possible. So I just want to remind you it's a typo. So on branch 2, if I want, or branch 1, if I want to do it named, I'd do IP access list. This time I'd use the keyword extended, and then give it a name, PC filter, and I permit my host. So really, it's almost like all you do is name it, and just take these sections. That's all I need. And put them under. Actually, it's a sub. That's why I have it tagged in or tabbed in, because it's a sub configuration command. You'll create this, and then under that you do permit IP host 10.10.110 going to 172.18.1.10 equal to web, and so on. So the same statement, same thing we did up here. It's just now we're going to do it named instead of numbered, and we apply it the same way. IP access group 100 in. So now let's go ahead and actually do the configuration and verify what it looks like. We have a really great debug command that's going to show us how our access control list is behaving. So let's go ahead and configure something and then just verify its operation. And then we'll be done. So in this one, we're just going to stay with our topology we've been using. We're going to say all hosts on the 10.10.10 subnet. So all of our hosts down here can go to the web of the server, or SRV. And just so that you guys know, because I'm going to do the verification, what I've done for this server is all I've done is configured really a separate router with IP routing disabled and the HTTP server enabled. So I will be able to open a web page and get to the web, right, of this guy. But he is, in the background, he is just a router running the HTTP service and not routing. So anyway, now you know that we're going to have, I'll let all these hosts go to the web, and then PC1 can ping and telnet to branch 2. And that's it. We're just going to leave it at that. So in order to write that, we're going to do a named access control list. So we do IP access list extended. We're going to name it host to server, or host to SRV. We're going to permit TCP 10.10.1.0, so everything on that network, going to the 172.18.1.10 host equal to web or HTTP. Permit ICMP, so that we now want to permit that takes care of this, right? Now we want to permit our ping and our telnet, so we permit ICMP host 10.10.1.10, going to 1.6, because I said it was branch 2, so here's 1.6, echo, right, because that's our ICMP echo command. And then next we want to permit the telnet, so we'll do a permit TCP host 10.10.1.10 host going to 1.6 again, but this time telnet, so equal port 23. So that's what we're going to go ahead and do. Let me bring, and we're going to do it, what? Where are we going to do it? Closest to the source, so branch 1. So I'm going to bring branch 1's console over, and we'll go ahead and configure that. Actually, I was going to bring my console over, and I decided to verify that PC2, because I'm going to only allow PC1 to ping and telnet to branch. Is that correct? Yeah. So let's just verify first that, in fact, before we even start, that PC2 can currently ping and telnet. It's 192.168.1.6. I just realized I don't remember if I set up telnet over there, so we'll see. Might not have actually even configured or allowed that transport input in. Oh. Yeah, I didn't. But let me fix that real quick. I'll fix it, come back to you. All right, I'm back. Hopefully this works. Basically, I had transport input none on the VTY lines on branch 2, so even if I could get to it, I wasn't going to get to it. So let's try this one more time. I'll hit the up arrow. Whew, it worked. It worked right away. And it worked right away, actually, because I also did the no login command. I don't see any good reason to do that in real life, to not force people to log in, but I didn't have passwords set, so that was a quicker way of just making sure I could go ahead and tell that in. And I can on PC2. So let's go ahead and just exit out for now. Now let's go over to branch 1 and configure our access control list. All right, IP access -list extended, tell it's extended, give it a name. And now see we're in that sub configuration I talked about earlier. We'll permit TCP. We're going to permit the whole network, right? So we'll do 10. Here, we'll hit a question mark. Yeah, our source is first. 10.10.1.0, get this out of your way. Then our wildcard mask, because we want the first 3 octets to match, would be 0.0.0.255. And our destination is our particular host. So it's going to be host 172.18.1.10. And we're allowing them to go to the web of that device, right? So that one's done. Next thing we want to do is we want to permit ping and telnet from just PC1. So we do permit ICMP host 10.10.1.10. Because I use the keyword host, I don't need a wildcard. Host tells it to match on every octet. And we're going to host 192.168.1.6. And again, we're going to the interface on branch 2, 192.168.1.6 that I can use. I can match on all of them. And equal to echo. This is our ICMP one, correct? Enter. What did I forget to do? Something. Oh, I know. We don't need echo. Well, let me double check. We'll hit the question mark there just to make sure. Yeah, I'm sorry. We don't need the EQ for that because we're not equaling that particular port. There we go. Sorry about that. Permit ICMP host, the host number, host, or the source host, then host the source, the destination host, and echo. ICMP is ready. Now permit TCP host. Now we've got to allow it to telnet, right? 10.10.1.10 going to 192.168.1.6 EQ port 23. Okay. And And we're done. Did we want to do an any on this one? Now we're just going to deny everything else. So we permitted our host, or we permitted our web stuff, and we permitted our telnet and our echo. Now everything else will be denied. So if we exit back, and now let's go ahead and verify that PC1 should be able to ping and telnet and go to the web. PC2 should only be able to go to the web of SRV. So I go back over to branch 2, the one we tested last time. Let's see if he shouldn't be able to ping that 192.168.1.6. Whoops. What did we do? Oh, duh. What did we do? We didn't apply it to the interface. Well, what did I do? I'm the one that did it. You guys are just gleefully watching, right? Let's go back and apply it to the interface. Oh, goodness gracious. So int, our closest interface was that gig 2. I better go back to our slides so I remember what my topology was here. Yes, gig 2. All right. Int G0/2 IP access dash group. Oh, what's the name? The name was host to SRV, correct? Oops. In or out? In or out? Talk about it the whole time, and I still gotta. We're gonna apply it coming in, right? Because we're closest to the source, and the traffic would be coming into branch 1. Let's do this. Let's now do a show IP access list to actually see what we've created, especially since I forgot to apply it and bouncing around on you a little bit. Extended IP access list called host to SRV, which is a little misleading because then I also allowed it to go to branch. That's all right. We have sequence numbers here, which will allow us to add or delete based upon number. So I could add a 15 permit statement that would go between 10 and 20. But anyway, we're permitting the TCP, everything on the 10.10.10, going to 172.18.110 equal to www. Notice I use the number. It translates it right over to the name, in a sense. We're allowing PC1 to ping, and we're allowing PC1 to telnet. Okay. I want to do one other thing here, and that is I want to turn on a debug command that's kind of useful. So show IP access list. All right. We also had an extra access list, if you noticed at the bottom of the previous one with extended test. I just got rid of it. That was old. That had nothing to do with our configuration here. Now I want to do a debug. So I want to debug the access list stuff. So the access list traffic. This is interesting, I think. Data plane. So if I debug IP access list data plane and then do this, so let's go ahead and what do we want to do? We want to go from PC2 first and verify that in fact he can't ping. And if he can this time, I got to figure out what else I messed up, right? But since we applied it to the interface, now we got the correct response. It's unreachable, right? And if we telnet to that same interface, because remember I could be very particular with my protocol. And I'm going to go back to our debug. There's a ton of debugging scrolling right now. I'm going to go back to that after we are successful and have a successful match. I'll show you the differences. All right. Well, we know that's not going to work, so let's just exit out of there. Now, what we can do, though, right, is go to the web of, let me open a browser here. So I go over and I open a browser. And let's go ahead and we'll go to the server, right? 172.18.1.10. And that's successful. I didn't have password set, so we're not going to actually go all the way in. But if I get this prompt, that tells me it's successful. So now let's go back to our debugging, which is really cool. Let's go first up here. On our first set of no matches. Holy cow, that's a lot of information, isn't it? But don't worry, I will highlight, we'll go through it. It's kind of cool, but I wanted to go to the original, the very beginning. Here we go. So the first thing I did was ping, seems no matching ACE in the ACL, host SRV, implicit deny. Because remember, I went from PC2 which I never made a match for. I permitted, sorry, we got stuff going on right now. I permitted PC1 to ping and telnet. I permitted 1 and 2 to go to the web, and I denied everything else. So it was absolutely right when it said there's no matching access control or access entry, right? Access control entry in the ACL. The ACL is host to SRV, so then we have our implicit deny. It's very descriptive, which is really cool, I think. Now if we go down, where's our permit? I think we've got one right here. Packet matched ACL. So this had to have been when we went to the web. And packet matched the ACL host to SRV sequence 10 action permit, which it is. Remember what sequence 10 was? That was our first statement. So if we do a show IP access list, our first statement is what allows us to go to the web. So that's how we know for sure that that's the one that matched, is that if we go up to our debugging, we find our permit statement packet matched ACL host to SRV sequence 10 action. When it found that access control entry, the action it was told to take was permit, so the packet matched and it permitted it. Hope that makes sense. You see the 10? The action is to permit, and we've had 10 matches on that so far. Okay. So now we couldn't ping or telnet from PC2, and we weren't supposed to. Let's go to PC1 and see that we can actually do that. All right, now I have the command prompt for PC1 here, and PC1, go to 192.168.1.6, correct? And it can, that's good. Can you telnet? And he can. So excellent. We'll go to the web browser on this one. You should be able to do this as well. And he can as well. So our access control list is working. And we can even see our different permit statements. So that's pretty cool. Let's allow PC1 to telnet to HQ. So let's go show our access control list again, just so I can get my name. Whoops, now I'm making things mad. Let's try that. Let's do it on debug all. I've made my point that it's kind of cool that it tells you exactly, how it matched and where. So let's do an undebug all, and let's do a show access list. All right, so we're going to add a statement in that allows allows PC1 to telnet to HQ as well. Maybe he's our administrator PC, and so now he gets to do stuff. So let's first type config T, right? Well, that IP. I want to hurry up. I don't like getting them this long. I don't like videos to get this long on you guys. Host to SRV. Whoa, don't make a new one by accident. Sequence number of 15. Permit TCP host, right? Hopefully I did this correctly. I didn't use the question mark, so. And this is PC1's address. Go to host 192.168.1.2. This is the IP address of the Ethernet interface connected to HQ. Oh, phew, no mistakes. It's always good. So let's do a show IP access list again. And I can be particular to my access list too. Now you can see between 10 and 20, I've added a statement. And you would want to order your statements from greatest amount of traffic to least amount of traffic. So I want to take care of the greatest amount of traffic that will be matched in my ACL first, right? Because you don't want it to keep processing. If I get, a gig of traffic or whatever, I don't know, that goes to the web, but only like 2 megs that are going to telnet to HQ, we want to take care of that web traffic first. Why make your router use all that CPU processing power to go through here and say, oh, not a match, oh, not a match, oop, not a match, oop, not a match, for a gig worth of traffic, over and over and over again. So you want to take care of your most prevalent traffic that will be matched to that ACL first, and that's why you would want to pick particular sequence numbers. I picked a sequence number because clearly my 3 routers don't have a lot of traffic on them. I picked my sequence number just to show you guys that you could just add one in based upon the sequence number, but you would want to build your access control list with your access entries handling the greatest amount of traffic first and working their way down. So that's it.